Hi, today we're going to talk about normal distribution. This is a very basic distribution and very fundamental concept which we need to understand in statistics, and is being used across in many disciplines like finance, quantitative finance, in certain central limit theory, or used in portfolio theory. So it's a- it's a very important distribution to understand. So by looking at it, there are few observations can be made. First of all, it's a continuous distribution and it's a bell-shaped curve. It can be described by mean and the variance, and it's a symmetric. The left hand side is equal to the right hand side, and the mean will always will be in the middle. And one of the properties is mean is equal to mode and it is equal to median, so all three lie on the same point. Kurtosis measure the height of this distribution. So normal distribution has kurtosis 3. Axis kurtosis is a concept which is kurtosis minus 3. The distribution which are taller than distribution, those are leptokurtic distribution, and the distribution which are smaller than this, which has a fat tail, they are called mesocritic distribution. Linear combination of random variables which are normally distributed also form the normal distribution. This is an important concept when we talk about multivariate distribution, where the multiple variables are involved, and they itself are normal distributed. So the combination of them also form the normal distribution, which we're going to talk about later. Normal distribution can be converted into a standard normal distribution, and standard normal distribution you compute by subtracting the observation with the mean value and dividing it by the standard deviation. We compute the z value, and z value is basically, it tells us the number of standard deviation above and below the mean. So after we convert into the standard normal distribution, so it will mean has a zero value, then we can see how many observation are within the within a particular standard deviation. So by looking at this figure, we can see that within one standard deviation, 68% of the observations are included. And if we just increase the value by 2 standard deviation, 95% of the observation can be covered between plus 2 standard deviation and minus 2 standard deviation. And when we increase to 3 standard deviation, you can see almost the entire area is covered. 99% of observation or that data is covered within this normal distribution. This is what we're talking about. So we can standardize these values, like instead of remembering 95%, 68%, 99.7%, those are not commonly used, but what is used is 95% confidence interval, how much the area lies. So it's 1 plus 1.65 standard deviation from the mean, and 95% is 1 plus mean plus minus 1.96. So these are a few critical values which we should know. I think 99% is a 2.54, so which we should remember. Thank you.